So, chapter 5 test. Page 1, pretty much here and at home, did pretty good on page 1. Were there questions? Max, pull yours back out so you can ask me questions. Because you're going to see all this stuff again, and we need to know all of this stuff so we can do later stuff. So, it's important. 5 was A, picking out the pluses and minuses. Good job. Let's see, C also, but you had some fractions. 7, this one was flipped, so you needed to think of this as going to infinity on the negative x's, and positive infinity for x goes to negative infinity on y. I draw a picture. So we did have some people miss this. This is an even one, which means the same end behavior. I don't care how many wiggles are in the middle, but they're both positive on the ends because it's positive and even degree. 8 was a matter of could you count all those zeros because there was a lot of them. But also, the definition of scientific notation is there's one digit before the decimal and then whatever other significant digits follow. So the rule is that there's one number right here. There can be more than one number after it as long as they're not 0. And then you have to count 1, 2, all the way up to 14 when you got here and you went negative because you went to the right. This is supposed to represent a very small number because it's a negative exponent. That's very small, and this is very small. I had some people miss number 8, so I'm going through it. Number 9, this is a 4th degree. If you take $1 and you divide it into fourths, each of those things, those coins, are called quarters. Okay, so this is a quartic. I don't know what it is that you need to help you remember that other than just memorizing it, but quadratics are 2. They both start with Q, but that's not enough. So quadratic is a square. This one is a quartic. So a 4th degree polynomial. The leading coefficient, y'all did good. You told me the negative. I want you to drop any variables. So if you gave me a variable here, you've already answered the variable question over here. I'd like just the number in the front, leading coefficient. Page 2. Any other questions? Okay. Number 10A. So here's the sticky wicket with this one is that students are really happy to apply the 3 to the negative 2 and make that negative 6. But you have to apply the 3 to all the bases. And one of the bases is negative 3. So you had to say negative 3 to the 3rd power. And then you had to say x to the negative 2 to the 3rd power. They both give the 3rd power. That gave you negative 27 here. The 27 doesn't go in the bottom. The 27 exponent is positive. It's 3. So 27 stays in the top. But this one is negative. X to the negative 6, it goes in the bottom. So when you were here, I expanded these directions to be negative exponents, and this should have been in the bottom. This one, some of you didn't simplify the 4 over 8, so rules still apply from 4th or 5th grade. If you have 4 over 8, you need to make that 1/2. Some of you magically moved the 2 to the top. I think you just got confused with the variety of things you had to do with a problem. But 4 over 8 is always 1/2. It doesn't change into 2. So maybe rewrite that and try that again and let me know if you have questions about that. I take those problems, I think I've said this in class, but I take whatever's negative and put it in the other place. So if it was in the top, I put it in the bottom or the bottom in the top so that I can look at it in a straightforward manner where I have all of the positive exponents and then I can just put them together. So I did this in 3 steps. I simplified the 1/2, but then no negative exponents, then I combined things, and then I compared top to bottom. Here I have 2 more x's on the top, so there they are. Here I have all the y's on the bottom, there they are. This is a process of being organized, and the more organized you are, the easier this type of problem will be. See, y'all did good on, obviously I didn't want you to multiply it out. Nobody even asked me that question because you assumed that I wouldn't make you, and you were right. Sum or difference, A and B. I mean, there were a couple of addition errors here and there, but generally speaking, 11 was fine. Number 12, some of you tried really hard with your multiplication, but there were a couple people who said these two multiplied together were just x to the 3rd, like you missed the 6 somehow. And that wasn't just one person, it was several people. So again, I think it might have been working too hard. But for the most part, I would say number 12 was handled very well. Factor completely. So here, take out a 5. This is an x to the 4th, so these are both x squareds. This test is a step up from our first factoring test, which was in chapter 2 or 3. So we were going to have the harder factoring here. And then this is a difference of squares. You had to factor it again. Look for those sneaky guys. They're always in there. This is factor by grouping. And the parentheses are really important. If you had told me this was your answer, 2x minus 3, this actually reads very differently, right? If you check this, you don't get this, because this problem says x squared plus, and then distribute the 2 only. So parentheses were really important and a necessity for the answer to 13b. So this is wrong. Don't do that. In case you're watching this video, and start there. Pause. Questions on 3? Next page. So I've drawn this. I'm going to draw it again. Greatest common factor. That's first. Then there's 2. Then there's 3. Then there's 4. 2s are stars. They are special. 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 This is special. You have to memorize it. It's called difference or sum of cubes. This is the sum of cubes. You had to find the base, then you write out the equation. Some of you tried to factor this again. Generally speaking, this won't factor again. So for future reference, just pretty much you can stop here. But if you try to factor it, check it and see if it works. Usually this is an imaginary solution, so it doesn't factor. But if you didn't memorize this, then I don't know what to tell you. Right here, when we did this chart, I said 2s you have to memorize. So memorize it. 3s are always 2 sets of parentheses, and this is factor by grouping, if it will factor. Otherwise, you'd have to use synthetic division. That's how it works pretty much every time. So 14, you should have used SOAP and used the rules for difference and sum of cubes. There are plenty of videos that I've posted where I've done this in class after class. You can go back and watch that or find it on Khan Academy, I'm sure. This one is a difference of squares, but special squares because it's x to the 4th. X to the 4th. This one factored again because it's also difference of squares. That difference of squares is a little devil. It comes back up everywhere. Here it is factored again, and x squared plus 4, x to the 4th plus 9 didn't factor because it's a positive. So if you factored this, then you're missing that rule. That is not as special as a difference of squares. 14. Questions?
Do you not factor for 4a, 4x squared minus 6x?
So what did you try?
No, I'm just wondering, can you not factor that smaller?
So people tried this. 2x plus 3 and 2x, oops, it'd be minus 3 if you were going to try this method. And then if you check it, you get 4x squared and you get minus 9, but what do you get in the middle? This is negative 6x, and this is negative 6x, and together they make negative 12x, which is not this. So you can definitely try it. Sure, try it, but check it. And if you can't check it in your head, check it on paper. And then scratch it out and say, oopsies, just kidding. I didn't mean to do that. It doesn't work. Okay? So generally speaking, it doesn't factor. 15, you were given this factor, so you knew to try it right here. And then you could factor from here, and I just wanted you to factor it. So read the directions, okay? Factor. You should know what it means to be factored. This is another form of the same equation of f of x. This is polynomial form. This is factored form. Both forms were on your project, specifically, lined here, right? Factored form. This is factored form. I didn't count off if you found the solutions, but I didn't ask you to do that, so it'll do that. 16, I did want you to find the solutions. There were only 2 possibilities for zeros, so you could try them. They both work. You could have factored it and told me that. I didn't write my zeros out because this was my test copy. Some of you told me that -1 was a factor twice. Good job. It just asked for the zeros. It didn't ask how many there were. So I was just looking for this. 17 was a quick gimme problem. Identify the number of solutions. When you go to factor stuff, like I said in this problem, you'd have 3 because this one, nope, +1 repeated. This one, you can just look at the equation and say you're supposed to have 5 solutions. Identify the number of solutions. Do not solve it. So if you go and solve it, then I know you're not reading the directions, because some of you have time issues because you like to check everything, which is fantastic. Or you're just thinking through what the, definitions or rules are. It's not a problem for you to think more. But when I ask you not to do stuff, then I need for you not to do it so that you can do the problems that I need you to do. Yeah? Okay. So 5 for that one, 7 for that one. People missed it. That makes me cry a little. But it was only 2 points, so I didn't kill you on it. 18, you were supposed to take the zeros, write it in factored form, multiply it out, get a polynomial. Y'all did a good job here, but there were a couple people who had questions. And again, I need you to know what all the different things means. It says write a polynomial function, which means it has to be many terms. And this is what we did in our project, so I wanted you to know what that meant. This one says write the factored version, do not multiply out. Y'all were like, sweet, I'm not going to. You didn't multiply, you didn't do more on this problem, so good job. If you answered number 20, but you didn't answer other problems, then you're not thinking, because it was extra credit. And I even said in class, don't do 20 until you finish the rest of the test. It's just good politics, okay? This is extra. This was a 1, 2, 3, 4, 5, 6, 7, 8, 9 degree, if you count them up. So it looks like this, sort of. It looks like this. So at the zeros, I put these two guys. It's going to bounce at -2 and +6, -2 and +6. There were a couple that I gave a couple points to because they were so close. But if you didn't give me the right zeros and you didn't give me the right end behavior and you didn't bounce anywhere, then probably you didn't get any points. Again, I graded this several days ago, so I don't remember exactly what I did, but it should have looked like this. Bounce, bounce, through, through, through. Some of you didn't list this one as a 0 at all, and I see it so much that I'm not surprised anymore. But it's the easiest one there is, okay? You don't have to solve for anything at all. It's just x equals 0. This is x plus 6 equals 0. A whole nother, step involved. This one's just done for you. X equals 0. So don't forget those guys, okay? And that was actually a 0 on here. Okay, I didn't really answer any questions. I just went through it. But did you have any that you need to see more longhand live version action on? Okay.